Okay, for my Zoom folks, I am about to share my screen with you, which I just did. If I could just get a show of hands to make sure you can hear me and that you can see my screen. Perfect, okay. So I know we're a few seconds early, so just hang on and we'll start in about a minute or so. Okay, so let's kick things off. What we got today is we're going to finish up with set operations. So finish set operations. Then I want to cover subqueries. Then SQL's DDL. And by the time we're done with today's lecture, you will be able to write pretty much any query you need on an SQL database, and you will be able to define the structure of an SQL database. So today finishes the first segment of the course, and starting on Tuesday, we'll start the next segment, which is how you design the database. So this first part has been more about how you use the database and create the database. We'll be moving into how to design the database on Tuesday. I did want to note that I changed the homework assignment slightly, not homework 1, but homework 2. So I know some people may have gotten an early start on it. On homework 2, problem number 2, I added a requirement that you use foreign key constraints that didn't used to be there. And MySQL in recent years has started enforcing foreign key constraints. So now is a good time to have you add them, especially because I want you to use them in your web projects later in the course. And then I simplified problem 7 because it used to ask for, it asked whether certain queries you make on a view are valid or not. And it used to be the question said if it was valid, then I wanted to show you how the view was resolved into queries on the underlying relations. I decided we didn't have enough time to cover that this semester, and it's also just not important enough to cover given our limited time. So I simplified problem 7. Now you just have to answer whether or not the query is valid or invalid. Okay, so questions about the homework before we start, because the first homework assignment is due this evening. Actually, I know it says it's due tomorrow morning at 6 a.m. Questions? I may.
Dr. Vanderzan, for submitting the homework, we're just doing for each question that you gave us 1.SQL, 2.SQL, and then you guys will run a grade script. And the comparison that's done, do we need to worry about anything as far as like trying to get the grade scripts to work? Anything to look out for, or just write the
So I
query.
would say the TA is going to probably have to worry about that. Basically, your select statement should be enough. So the question was in the .sql files, is the anything that you really should worry about? And I would just say that use as long as the select statement will print out a table, and essentially the script compares the table that gets printed out with the table that we expect to be printed out. Someone did ask a good question on problem 9. It's a problem where you update, and it would be nice if in addition to updating, you were to print out the entire table after the update. We don't care about printing it out before the update because we know what it looks like before the update. So that would probably help out the TA if you could put a select star statement after the update. But if you've already submitted the homework assignment, don't worry about that. Okay.
Okay, so we just write the code and have the finished table print out at the very end, and that should take care of it.
Yes, exactly.
Okay.
Yep. Also, I just saw on chat, someone was saying that they got partial credit on the last Canvas quiz and not on this one. Here's the issue with Canvas quizzes. If it's a multiple answer question, the algorithm that grades it giveth and taketh away. So it gives you points for each correct answer, but it takes away points for incorrect answers. So if you have 2 correct answers and 2 incorrect answers, you get a 0. And I can't do anything about it. That's just the way the Canvas system grades multiple answer quizzes. So that's why it may look like in one case you got partial credit for the question, and another case it looks like you don't. And the case where it doesn't look like you got partial credit is probably because the number of answers you got wrong was equal to or greater than the number of answers you got right. Okay, other questions? Okay, so very quickly, you may remember that I said at the end of the period last time that union is supported in MySQL, but intersect is not, and set difference is not supported either. So there is a way to make that happen. Oops. Got the wrong, I think I have the wrong, yeah, I do. There we go. So there's 2 ways that you can write an intersection in MySQL. So suppose you have 2 relations, R and S, and the common attributes are A and B. So you want to do an intersection and get all the tuples from R and S that agree on the attributes A and B. So if nulls are not an issue, then you can use a natural join, because a natural join is essentially intersection. And then you simply select distinct to get rid of any duplicate tuples, because intersect gets rid of duplicate tuples. So natural join works perfectly because it is intersection. If it only includes a row from R and a row from S if the 2 match. If you want to pick up nulls, which would be a bit unusual to want to pick up nulls in the join columns, or pick up nulls in these things, just because you then probably have a huge number of matches with nulls. But you can use the code called spaceship operator to pick up nulls in that case. So you couldn't any longer say natural join, but it's still a natural join, except you're using the spaceship operator down here to pick up nulls. So if A is null in R and A is null in S, that would be considered a match. So essentially, the key idea here is if you want to do an intersection in MySQL, use natural join on your union attributes. Okay, and you do it on all the attributes because that's what you're looking for, is commonality across all attributes. Then set difference, again, it's in SQL, but not in MySQL. So here, I am showing how you can get set difference. So I want all tuples in P that are not in Q based on ID. So all IDs in P that are not in Q. And there's two ways to do it. The first is actually to use a subquery. So we get to a subquery today, but we select star from P where PID is not in, select ID from Q. So if P.ID does not match any ID in Q, then it works. Okay, so as a simple example, right there, you see that in P is 3, 7, and 8, and in Q it's 3, 6, and 4. So we ask whether 3 should be in the result, but we find that when we do the select statement, actually I'll put it back on full screen again. So we find that 3 is in fact in Q. So it would not satisfy this predicate. 7, on the other hand, would satisfy this not predicate because 7 is not in the IDs that you get from Q. And 8 is the same way, it's not in the IDs you get from Q. So this statement right here essentially is the exact definition of set difference. Right? Set difference says I want everything from P that is not in Q. So this is the literal, this statement here is the literal definition of set difference. Now, another cute way you can do it, I'd probably do it this way because it's the most straightforward. But another way you can do it is to select star from P left Q join, and then ask for in the result anything where Q.ID is null, because if Q.ID is null, it means that we did not match that tuple. So the left join will ensure that all tuples in P are included in the result. And then any P that has a null for Q.ID, it means it didn't match any tuple in Q, and therefore it should be part of the set difference. So in this case, this would be the result of the left join right here. You can see 7 and 8 get nulls because they don't match anything in Q, and those are the two tuples we want. So this is a slightly more opaque way of writing set difference, but it works equally well.
Dr. Van der Zinnen, the A method, what does that exactly return? I'm trying to think. It'll go through all of P, and then not in will return.
So what it is effectively, it says for each tuple in P, check to see whether that tuple is in the set that is returned here. So the way the query processor is processing A is basically, it's saying for each tuple, an element of P, if P not in a set returned from Q, then include in result or add I'm sorry, if T, add T to result. So effectively, that's what you're telling the query optimizer to do, is to go through each tuple in P. For each one, check to see if T is in the set return from Q. If it's not, then add it to the result.
So for A, we would only see 2 rows in the resulting table.
Yes, you would see 7 and 8.
Okay,
Right.
I was just trying to make sure that so B has a different, would result in a different looking table.
No, it would actually, both of them would have the same. Oh, I see what you're saying. I needed to, no, actually, both of them will have the same result because a left join only includes columns from the tuple on the left-hand side. It doesn't include tuples on the right-hand side. Both of them, so both results are just going to have one column, which is PID.
Okay, right. Okay.
Because a left join does not include any of the, okay, that's a good thing to know is, no, that's not true. The left join would actually, yeah, but I said select star. Oh, no, actually, you're right. You are right. I would need to just select the attributes from P. I was wrong. For B, I actually need to change that. I really need to say select P.ID because otherwise you would get a table that would be 7 null and 8 null. So in fact, to make this one work, it actually has to be select P.ID. You're right. This will make the tables be the same.
Okay, yeah. Okay.
Yep, you're right.
Just making
Otherwise,
sure, yeah.
I would have gotten the stuff from the null columns from Q as well. So now the two outputs will be the same.
Thank you.
You're welcome. Thanks for the question. That does clarify it. Okay, and then finally, someone did send me how you can, there is no full outer join in MySQL, but you can actually easily create a full outer join. So if you have relation A and a relation B and you want to do a full outer join, the way that you can do that is to say select star from A left join B using whatever the common columns are. So let's say the columns are, let's say this was X, Y, Z, and B was X, A, B. You say using X, union select star from B, I'm sorry, from A, right join B using X. Because all a full join is, that's exactly the definition of a full join. So this is a full join. A full outer join. And the definition of a full outer join is literally a left join union with a right join. The left join gets all tuples from A, putting nulls in columns from B that don't match. The right join gets all tuples from B, putting nulls in the columns from A that don't match. So that is a full outer join in MySQL. Okay, so questions about set operations. Okay, so in that case, we'll move on and we'll tackle subqueries. So a subquery, you've already seen some of them, is simply a query that contains one or more nested select statements. So for example, if I want to list the staff who work in the branch at 163 Main Street, one way to do that is to select staff. These are the staff from staff where the branch number equals. And now this right here is a subquery because it's nested. It selects the branch number from branch where street is 163 Main Street. And what happens is that SQL satisfies these select statements from the most deeply nested one out. So it starts with this one because it's the most deeply nested, and it will resolve that one to B003 because that is what the branch number is for the branch that's at street 163 Main Street. So once it is resolved the innermost select, it's ready to execute the outermost select, and it would return all staff at branch B003. So in fact, almost all subqueries can be implemented with comparable joins. So this is just, subqueries are often syntactic sugar, and it just depends which you're more comfortable with writing, because I could have written the same query this way. I could have simply selected the staff from staff, comma branch, where the branch numbers are equal and the street is 163 Main Street. So in many cases, subqueries are simply syntactic sugar, and you could write an equivalent join query with it. I don't care which way you do it. If you feel more comfortable with subqueries, use subqueries. If you feel more comfortable with joins, use joins. Although on the exam, I may tell you you have to use a join because I do want to make sure that you know how to write joins in this class. So there are three types of subqueries. The first is a scalar subquery, which you just saw. It returns a single value. And another example is one where we want to list all staff whose salary is greater than the average salary, and we want to show how much their salary is greater than the average. So in that case, we can write the same, you can see the same subquery is written twice. So up here, salary minus select average salary from staff. So this select average will be evaluated and will return the average salary, which will then be subtracted from salary. And then you're selecting only staff whose salary is greater than the average salary. And this query optimizer isn't stupid. It should only satisfy this query once because it's not going to change its value. So it's not like you are creating inefficiencies by writing the query this way. Okay, so if the average salary is 17,000, then the query would resolve as this. Once the inner select statements were executed, both of them would be replaced with 17,000. So the query would resolve to salary minus 17,000, where salary is greater than 17,000.
Dr. BZ?
Yes, go ahead.
Oh, sorry. Real quick, the subquery versus the join way, is one more efficient than the other? The Zybook yesterday, and I did what said that the subquery will be executed for every row of the table. So does that mean that does a join maybe make that process more efficient?
The join may make it more efficient. The query optimizer, though, is pretty smart, and it might be able to figure out, like using its knowledge of patterns to convert it into a join.
Okay, so
General,
it goes to some kind of like compiler type of
yes,
optimizer, something like
yes.
that.
Every
Oh, okay.
query is compiled and then optimized. So there's no guarantee. That's why you shouldn't try to write out. The point actually with SQL is not to try to write the query efficiently, is to write it as straightforwardly as possible. Because the idea is the query optimizer is pretty smart and it should be able to figure out the best way to implement it. Yeah, so
That's
what you
very
said
nice.
was right.
Okay.
Essentially, the query goes through a compiler. And the compiler is pretty good at making the resulting query efficient. So I really do think you should just write the query in the way that's most comfortable for you, that for you best expresses what you want, and don't worry about efficiency.
Okay.
Other questions? Okay. So you can also use SQL variables to store intermediate results if you want. They can't store tables. They can only store scalar values, and you prefix the variables with an at. So for example, select at average salary, colon equal average salary from staff. And now you could say select those staff members where the salary is greater than at average salary, and you could subtract at average salary. So it might make the query a bit more readable. It shouldn't make it more efficient. And someone asked the other time if when you, I believe they asked if you assign into a temporary variable, can you suppress the output? And the answer is yes. If you say select the whatever it is into the temporary variable, that will suppress any output. So it would make the assignment of average salary to at average salary, and it would not print it out. So feel free to use these intermediate or SQL variables in your homework. I'm fine with it. Just you can't use them with tables. Okay, they can only store scalar values. Okay, so that's scalar subqueries. Again, a scalar subquery returns a single value. The next type of subquery is a row subquery, and it returns an entire relation. And we use subqueries to compute intermediate results. So earlier, when I showed you how to do a full outer join, this actually was using two row queries, okay? This produced a table, this produced a table. Each of them was an intermediate result, which I unioned together to get my final result. Okay, so that's one example of a row query. And now I'll give you a more sophisticated example. So let's say I want to list the name and score of the top scoring student in each course. Okay, rather than, I'm going to walk you through this rather than, and then I'll come back to this slide. So I want to list the name and score of the top scoring student in each course. So this goes to my student courses. I have select star from student courses, and you can see it produces a whole bunch of students and what their score was. So I want the name of the student, the name of the course, and the score. Okay, well, the first thing I can do is I can find the maximum score. I can say select course ID, comma, max score as top score from student courses, group by course ID. And this gives me the top score in each course. But I can't associate the student ID with that because the student ID is not part of the group by, or it was not part of the group by. So I have part of what I want, but I don't have everything. But now I can say, okay, in order to print the student name associated with the top score, I can first get the student ID. And the way I can do that is I can take this result table and I can join it back with student courses. If I join it on the course ID and the top score, that's like an intersect operation. It will give me anyone, for example, that got 100 in AC 102, any student who got a 100 in AC 102 will successfully join with this tuple right here. So what I can do is go back and say, okay, now let's select student ID. And I'll say, actually, I need to be, I'll say sc.studentID. Then I'm going to use, call this max score dot course ID. And I want max score dot top score. Whoops. It's not letting me, I'm going to have to write it out. Okay. So I want those three. I'm going to select from, and now I'm going to use that table I got here as an intermediate result. So I'm going to select from it the course ID, and the max score is top score. So I'm taking the relation I generated and I'm putting it in quotes because it's now a subquery. I'm going to name that intermediate result max score. And then I'm going to join with student courses on the course ID and on the score, top score equals SC dot score. So I need to match both attributes. Okay, so what this one is doing, I know it looks fairly complicated, so that's why I'm doing it one step at a time. The first step was to produce this table with the top score in each course. So now what I'm doing is that's this table right here. I'm using it as an intermediate result, and now I'm joining it back with student courses to obtain the student ID associated with the top score. And I'm doing that by joining on the course ID and the top score. So I want any tuple from student courses that matches the top score and the course ID to be printed out. This is very long, so I'm not sure, but it worked. So now I got the student ID associated with each course. And now the last thing I need to do is take this result and join it with the student table to get the names. And I'm not going to show you that, but I'll show it to you here. So this right here got me my table with the top scores. Then I joined with student courses to get the student ID. And then the very last thing I do is join with student on the student ID. And that gives me the first name and last name. So I'm getting the course ID from SC. I'm getting top score from here. First name and last name is coming from student. So what I tried to do there is show you how I came to this rather complicated query. I started by just doing this innermost query first. Then I thought, okay, once I have that, can I get the student IDs? How can I do that? I can rejoin it with student courses. Okay, that gives me the student ID. Now, how can I get the student's first and last name? Well, I can reach into the student relation based on the student ID. So that's how you can kind of build up a complex query one step at a time. And how you can use a row subquery, like I have right here, to create intermediate results along the way. It simplifies the creation of your final query. So questions about this, because I know this isn't a simple one, but it really is a nice example of the use of row queries. Okay, so we've shown you two types of subqueries, a scalar subquery and a row subquery. The third one is called a table subquery, which is confusing because really a row subquery is a table subquery. And a table subquery is really a column subquery, but that's the way they're labeled, so you just got to roll with it. So at any rate, a table subquery returns a single column and it's suitable for use within. So you saw me use a table subquery for set difference. Okay, when I did set difference, this right here is a table query. It's a subquery, and notice how I'm using it with an in statement. So I'm basically returning a set. You can think of a table query as returning a set. So another way to think of a table subquery is as a set subquery. So I'll just put up here, if it makes you can think of it as either a set subquery or a column subquery. I think of it as returning a set. And then what you're doing is checking to see whether something is either in that set or not in that set. So here we want to list the properties that are handled by staff who work in the branch at 163 Main Street. So what I want is all staff who are, so first of all, I can write a query that returns all the staff who work at the branch in 163 Main Street. So that's this query right here. Select staff number from staff, where branch number equals. So this one is a scalar subquery. So you saw this earlier. This is returning all staff that work at 163 Main Street. And then we're selecting all the properties from property for rent, where the staff number that manages that property is in the set of staff at that work at 163 Main Street. And though you don't see it here, staff number is a attribute in property for rent. So if you're wondering where staff number comes from, it's one of the attributes in property for rent. So we're saying select all tuples from property for rent that have a staff number which is in or matches one of the tuples from the branch at 163 Main Street. Okay, so that's a table subquery. And again, you can do this with a join. So here it is, selects the right down here. This is very verbose. This is very succinct. Select star from property for rent. Natural join on staff. Natural join with branch where the street is 163 Main Street. So basically you're selecting from branch, the one branch that has 163 Main Street, and you're natural joining that with the staff. So that gives you all the staff that work at that one branch. And then you're natural joining those staff with any property for rent that matches one of those staff numbers. So you can do it with two natural joins as well. And you may have to look at that a little while to convince yourself that it's right, but it is. Okay. So finally, just a few rules for subqueries. One, you're not supposed to use an order by clause because it isn't really supposed to affect anything. You're not really printing out the subquery. So there's no reason to use the order by clause. If it's a table or scalar subquery, then the select list can consist only of a single column name. But if it's a row query, it's producing a table, so it can be as many columns as you want. And by default, the column names in a subquery, this is like nesting. What this is saying is the scope is that if you reference a column, it first looks at the select clause for the subquery. If the column is undefined in that select statement, then you go to the outer select statement. So the idea is if you have let's say you have R has A, B, and C, and S has X, Y, and Z. And you have select ... from R. Say R, and you say some operation. Let's say you say natural join and now you have select star. Let's say we have select star from S where X equals A. So here and let's assume X is also defined in R. So here, this X comes from S because S is the most closely bound select statement. So this X comes from S, but this A comes from R because A is not defined in S, but it is defined in R. So basically what that statement in the PowerPoint slide is saying is you follow the same rules for scope that you do in a programming language. You look for the most recent definition of that attribute. So in right here, the most recent definition of X is in S. The most recent definition of A is in R, as far as your scope.
Would you say, Dr. Van Zen, that you would want to use the dot operator, maybe name it, so just in the off chance that they happen to have the same attribute name
Yes,
that you
you
want
can
to compare?
certainly do that to make it really clear, or if you want to go to the outer one and skip the inner one. So I could have, I don't want to go back to that whiteboard, but if I'd said where r dot x equals a, then it would have been taking the x from r because you explicitly said where to get it from. So yes, you can always prefix the attribute name with a relation, and that will make it unambiguous which one you want. Does that answer the question? Oh,
Yes, it does. I was looking
Okay.
for my mute button. Sorry.
Okay. And finally, when a scalar subquery, so this is really just referring to a scalar subquery because row subqueries can't be used in a where clause. But when you're doing a comparison, and really the only time you can do a comparison is with a scalar, then the subquery must be the right-hand side. So this would be illegal because the subquery is on the left-hand side of the comparison. I have zero idea why they defined it that way, but in the standard, it's like that. So scalar subqueries are always supposed to be on the right-hand side of a subquery. Don't ask me why. I'm sorry. A scalar subquery is always on the right-hand side of a comparison. It's never on the left-hand side of a comparison. Why that requirement is there, I do not know. Okay, and I don't have time for this today. I'll let you look at it. It was an exercise. It turns out it's a fairly involved exercise to try to write all guests currently staying at the Grosvenor Hotel using a subquery, but I showed the answer for how you could do it using a subquery. So don't worry too much about it. The one thing I will warn you about or tell you about is when you're trying to find if a hotel room is occupied, you can say that it's occupied if the current date is between the date from, and you can't say date to because we assume, I tell you in the homework assignment that the date they check out is not one of the days the room is occupied. So you actually have to subtract 1 from the date. And here's the way you can do it. Date sub, and you say date 2, comma, interval 1 day. And that will subtract 1 day from date 2. And we're going to get to date sub in a moment, so I just wanted to point that out. So questions about subqueries. Okay. So the last thing we want to talk about data definition language, and we can get to them, views. So I'm going to go fairly quickly through a bunch of slides because many of them are fairly obvious. So basically, data definition allows you to create and alter tables and specify the fields and their data types, specify integrity constraints on the data, and define and maintain views. So those are the 3 big things you do with the data definition language. So there is a bunch of types in SQL that you're not going to be familiar with from most programming languages. So first of all, there's date, time, and timestamp, which are not built-in data types for most of the compiled languages. There's an interval, which is a time interval. And then there are multiple ways you can store numeric data exactly as opposed to approximately. In programming languages, you can typically only store data approximately if it's a decimal number using float or double. But in SQL, there are exact types for representing numbers. Okay, and then, so Boolean values, true and false, are the literals for Booleans. For character data, you choose between char and bar char typically. Char is a fixed width field and pads with spaces if to the right, if the string is too small. Varchar, by contrast, will allocate a exact length string for that field. So if it's a 10 character value, it will get exactly 10 characters rather than 30. So 30 simply puts an upper bound on the size of the string. Both of them can store up to 255 character strings, although I've found that I can use varchar and rmysql for larger strings. So this must be an SQL standard. And then text is supposed to be what you use to store longer length strings. But as I said, I've been able to store varchars that are longer than 255 characters. Now, the difference between char and varchar, varchar is more space efficient because you don't waste space on short strings. Char is more time efficient because every record ends up being a fixed size, so you can treat it more like an array because every record will have a fixed size. Therefore, on the disk, it's easier if the records are stored contiguously to jump directly to the right record. Whereas with varchar, every record will have a different size, so you basically can't use array indexing on relations that use varchar. So it's a trade-off between speed. Chars, if every field in a table is a char, it tends to be faster to access tuples in that relation, but because the fields may be too big, you may waste space. In contrast, varchars will assure that you take the minimum possible space to store a tuple on disk, but then the trade-off is you may not be able to access it as quickly. Okay, numeric data. In programming languages, it's often not necessary to be able to precisely represent a decimal number. But banks and financial transactions, it is absolutely essential that you be able to precisely represent things like 33 cents or 1 cent, 0.01. Even representing it as if you say 0.32999, that's still not 0.33. And when you have millions of transactions, even a discrepancy of 1/1,000,000th can add up over time to real money. So there are certain things that you may want stored precisely, and numeric or decimal gives you the ability to do that. You specify the total number of digits and the digits after the decimal point. And they're stored as strings, but they can be manipulated like numbers. Okay, so definitely not as efficient, but they will precisely store it. In contrast, if it's okay to just have approximate numbers, you can use float instead, float or double, just like you would in a conventional programming language. Okay, dates. The format is 4 digits for the year, a dash 2 digits for the month, a dash 2 digits for the day. They're considered string literals, so you have to put them in single quotes. Then time is in this format, hours, minutes, and seconds. And timestamp will give you both a date and a time. And I believe you can get more precise than just, I think you can get down to thousandths of a second. I forget how, but it's more common to just stop at the second mark. So here's some handy functions for dates. Now we'll return the current date and time. Current date returns the current date, which you probably have already used in your homework. Current time returns the current time. Date add and date subtract allow you to add or subtract time intervals from dates, which is handy. And date diff allows you to compute the number of days between two dates. Very handy in the booking relation for calculating how many days someone is staying at a hotel. So these functions, very handy. You may want to write them down, or they're on slide 8 in the DDL. So then an interval allows you to indicate a time interval. So for example, a race result is a time interval. Time is an exact point in time. So time is an exact point in time, or is meant to be an exact point in time. Interval is meant to be a difference between two things. So like a race result would be an interval, the amount of time required to run a race, although I know you could also technically store it as time. So for example, you could say an interval, you specify the most biggest part first, so year down to month. This would represent anything from 0 years to 99 years, 11 months. Here, I'm down to hour 2, down to second 4. So this gives me an interval down to 0.999 seconds. So this actually gives you how many thousandths or hundredths or tenths of a second you can go to. So 1 would be tenths of a second, 2 would be hundredths of a second, and so on. Okay, so here I gave an example where you use an interval to do subtraction, subtracting 1 day from date 2. Okay, so those are the data types. The big ones that are new are dates and precise numeric types. So the next thing we care about is integrity constraints. And remember that there's 4 in the relational model. There's entity integrity, which says that you have to have non-null values for your primary keys. There's null, which allows you to store an unknown value. There is relation or referential integrity, which means every foreign key either references a valid primary key in another relation, or all the fields of the foreign key are null, and they're general constraints. And on top of that, SQL gives us a 5th type of constraints, which is domain data. So it is a set of legal values for a field. You can constrain the set of legal values for a field. So in SQL, if you want to say that something is required, you say not null. If you omit not null, the assumption is that null is a reasonable value. is an acceptable value. But if you say not null, that is saying it is required. So any primary key, the attributes in a primary key have to be declared not null. Then domain constraints allow you to restrict the values that are can be used from a domain. So a few slides back, I showed you all the different types you're allowed to choose from, but sometimes you want to restrict the values that can be chosen from that particular domain. The way you can do that in SQL is with the check keyword. So the general form is check and then some search condition. So for example, we can say check that semester is in this set, fall, spring, summer. So now, even though semester can be a char, we're restricting the values it can take to be fall, spring, or summer. So we can put this check clause right with the declaration of the attribute, or in SQL, we're allowed to create new types. Just like in C, you have type def, and you can create classes or structs. Here, you can create a new type by calling it create domain. So give it a domain name as, so you specify the data type. You can provide a default value for that domain, and then a check that will restrict which values of that data type are valid. So here I create a domain called semester type as char2, check the value is in fall, spring, or summer. Now when I declare semester, I can declare it as semester type. So this is helpful when we want to reuse the domain multiple times across multiple tables. And the check condition can involve table lookup. So here we're creating a domain branch number, and we want to restrict it to the current branch numbers in branch. So which makes sense that if you're declaring, say, a foreign key for staff, you may want to restrict the branch numbers to be a valid branch number. So here, that's what we're doing. We're saying that while branch number can be a 4-character string, in fact, it's the only allowable values are those that are in the branch numbers from branch. Okay, so
Dr.
typically
BZ?
your check has an in it. You're in some set. Yes, question?
Yes, when you create the domain and then you move on, and later on you insert another branch number, does that domain automatically, does that check
Yes.
automatically update, or is it stay the
Yes.
same?
Yes. So the question was, when you create this domain, is it static in the sense that the values that are valid are collected at the time the domain is declared, and thereafter the set cannot change? Or is it dynamic, meaning if I add and subtract branches from the branch relation, will the set of acceptable values dynamically change? And the answer is the set of values will dynamically change. So if I later add a new branch to the branch relation, then this domain acquires a new branch. Other questions? Okay. So moving on to our third type of constraint, entity integrity. So a primary key of a table must contain a unique non-null value. So when you declare something as a primary key, you are declaring implicitly that it's unique. So there's a primary key keyword, and in parentheses, you put the attribute or comma separated set of attributes that are the primary keys. And there can be only one primary key per table. If you want to have alternate keys, you're allowed to say unique and have one or more attributes in the parentheses, and that will say that that is an alternate key, and also that they must be unique. Okay, any field declared unique must also be declared to be not null, because you're declaring it as an alternate key. And finally, you're allowed to use this auto increment on integers. So oftentimes we want to have an artificial key. We use ints. And if you declare it as auto increment, then when you insert a new tuple, MySQL will automatically select a unique key for you so that you don't have to. Remember, when you insert, it can be hard to select a unique key. So one easy way is if the primary key is an integer and you declare it as auto increment, then MySQL will always keep track of the last ID assigned. And when you insert a new tuple, it will add 1 to the previous ID and assign that as the new ID. So that's entity integrity. Referential integrity is that we can't have dangling pointers, that foreign keys must reference a legitimate primary key in another relation. And the way that you declare that is to say foreign key, then the name of the key in this relation references branch, and the assumption is that branch number is the primary key in branch. If that's not the case, then you would also give the primary key, the name of the primary key. So if instead branch number reference branch ID, you would have to put in parentheses ID right here, right after branch. Okay, now, with foreign keys, you have to be careful because if something is deleted from the parent, let's say that you have a situation so let's say that you have a branch relation and you have in it B003 and some other information and a staff, and you have some staff S01 and they work in branch B003. Okay, what happens if A, we delete branch B003, and 2, if we modify B003, say we change it to B005. Well, if we delete B003 and we don't do anything down here, we would have a dangling foreign key. We would violate referential integrity because B003 would no longer exist up here. It's gone. So we have to specify what happens if we delete the primary key to which the foreign key points. And there are 4 options. The first option is you can cascade the change. So that means you would delete the corresponding tuples from the child. So in this case, any staff working at branch B003 would be deleted from the staff relation. And then if in turn if the staff number was a foreign key for another relation, then the tuples that depended on those staff numbers would be deleted. So that's option 1. You can cascade the delete. The second option to maintain referential integrity, it's okay to set the foreign key to null. So that's option 2, is you simply set it to null. The third one is you set it to a default value. Maybe there's a headquarters branch like B001. So when you delete the branch, you temporarily assign all staff in that branch to the headquarters branch. So that's set default. You set it to a default value or a default key that you know it always exists. And the last one is you reject the delete. So no action says you reject the delete, it's not allowed. And that's the default if you don't specify one of the other 3 actions. So if you were to just say back here, foreign key branch number references branch with no specification of what happens on a delete, the delete would be rejected in branch. It wouldn't be allowed. So that's the default. Now with update, cascade means you cascade the update. So if I change branch B3 to branch B5, then every staff that used to point to B3 would be updated to point to B5. And then set null, set default, and no action have the same meanings as for delete. Okay, so for example here, I say foreign key staff number references staff, on delete set null. So that may look, that might be, for example, for a property. So for a property for rent, the foreign key is staff number, it references staff. On delete, we still want to manage this property, but temporarily no staff members assigned to the property. Okay, foreign key owner number references private owner on update cascade. So when the owner number changes in the owner relation, we want to update that owner number in the property for rent. Okay, so you need to write these foreign key constraints in the homework assignment that you'll be doing. That'll be due not this Friday, but next Friday. Okay, then you can use the check command outside of a field definition to define general constraints. So we have constraint staff not handling too much. We want to make sure that no staff is handling more than 100 properties. So here we have select staff number from property for rent, grouped by staff number, having count star greater than 100. So we're collecting all staff that manage more than 100 properties. And actually what we're saying is we don't want that to be allowed. So we say check not exists. And if you try to insert a new property for rent that would violate this condition, the insert would fail. So this condition would be checked by the SQL optimizer when it does the insertion. So this is the way, using the check statement, that you're able to implement general constraints. And they're done outside of the field definition, and you name them. So you start with constraint, name of the constraint, and then the check condition. Okay, so there are some limitations in MySQL. Create domain is not supported at all. Check is parsed but not enforced, meaning they hope in the future to implement the check command, but right now it's not actually enforced. They do have an enum keyword so that you can enumerate a set of allowable values. So I could say semester enum, and it will be limited to one of these 3 values. It used to be that foreign key constraints were not enforced, but they are now. This should say foreign key constraints. So foreign key constraints are now enforced. They did not used to be. So MySQL is public domain, and therefore things get done more slowly. So why in the homework assignment do I say you have to use these other things even though you can't check to see whether MySQL enforces them? It's because you should know how to do this if you go out in the real world and use a full-blown version of SQL. You should know how to use create domain. You should know how to use check. So in the homework assignment, I actually make you use them. You're just going to have to the homework assignment describes how you can work around some of these problems of not being able to see whether they actually are syntactically correct or not. Okay, so finishing up, putting it all together, we can create a table by saying, using the create table command. Informally, you say the table name, then you have your column declarations, then you indicate what the primary key is, then you indicate what are the alternate keys, then you have your foreign key declarations, and you end with your general constraints. And these are all comma separated. Okay. The next slide has a much more formal definition of it that I'm not going to go over. I'd much prefer my informal definition. But here is a example, and I know I'm about to run over by a minute or two. I will just give this example and then I will wrap up. So the property for rent relation has a primary key, which is property number. It has a street, city, postcode, property type, blah, blah, blah. So I'm going to first create a number of domains, one for the owner number, so that I ensure that I only use valid owner numbers. I'm going to create a domain for staff number, so I only can reference valid staff numbers. Then I create a domain called P number as a varchar for no particular reason, because that doesn't really help me. And I create a domain property rooms as a small int. And I check that the value is between 1 and 15. So here I'm not allowing the number of, I'm restricting the number of rooms in the property to be between 1 and 15. And on the next slide, here is the create table. So create table property for rent. I define my column. So property number is a P number, not null. Rooms, and you can see it's P rooms, not null, with a default of 4 rooms. The rent has a default value of 600. Owner number has owner number, not null. Staff has a staff number because I do not say not null, it may be null. Then I have my constraint staff not handling too much, and I couldn't put it all on this slide, so you'd have to go back to the previous slide to see how I defined that. But I'm associating it with the staff number rather than putting it at the end. I could also have put this constraint at the end. This constraint staff, I could have put it at the end. When I'm done with my columns, notice they're all comma separated. I specify the primary key, then a comma. Now my foreign keys, so staff number references staff. On delete, I set it to S001. So in this case, I want, if the staff member managing this property for some reason goes away, I automatically assign them to staff 001. On update, I cascade. Okay, so that is an example of create table. Now, I did not get through all of the slides for today, and some of those slides are for the quiz. So what I'm going to do is push the quiz back so that it's not due until next Thursday, because on Tuesday I will finish up these slides. And so the quiz is pushed back. Today's quiz is pushed back until next Thursday. I will finish up this lecture on Tuesday, and then we will have a segue where we talk about the relational algebra and calculus on Tuesday. And that will be the relational algebra and calculus forms the formal basis for the for the data manipulation language, or for SQL. And then after that, we'll start with design of your database. Okay, so with that, I will let you go. If you have questions, feel free to